Welcome to Data Skeptic. Data Skeptic brings you discussions about how data is changing our world. Our interviews are conversations with thought leaders in topics like data science, machine learning, and artificial intelligence.
Our interview today is with the authors of the recently published textbook, Artificial Intelligence in Games. Naturally, AI is very useful to game developers who want to define the behavior of their non-player characters. In addition to that, however, I learned about other ways in which AI is useful for the game development process. More about that in just a bit. Everybody learns in different ways, but there are some truisms about effective math and science learning, like the fact that it should spark questions and excite you. Those are 2 out of 8 of the principles of learning that the folks at Brilliant.org put together. You've got to head over to their site to find out what the others are, but I'll give you just one more for today. It's number 3. Effective math and science learning is active. I'm glad you're listening to Data Skeptic, and I hope you learned something, but to really learn it, you need to put that knowledge into action. If you need a more active learning experience in your life, I'd like to recommend Brilliant.org's courses to you. You know, my oldest nephew is deep into the Rubik's Cube right now. I knew group theory was the mathematics that describe Rubik's Cubes, but I never really got into the details. So on a hunch, I went over to Brilliant.org to check and see if they had a group theory course. Yep, of course they do. I started learning and taking quizzes almost immediately, actively applying the learnings I got. That's how you get knowledge to stick. To get more active learning in your life, head over to brilliant.org/dataskeptic and see what they have to offer. That's brilliant.org/dataskeptic.
I'm Julian Togelius in English pronunciation, or Julian Togelius in Swedish pronunciation, but don't do it in English.
All right.
And I'm Yorgos Yanakakis in Greek pronunciation.
So this past couple of weeks, I've been going through your guys' book and really enjoyed it. Who do you think the book is for? Is this for AI people, games people? I assume all of the above, but who did you have in mind when you started writing it?
I think we had in mind people who already know the basics of AI to start with, because we could write a book that would get you going from the very beginning for people who basically know nothing, but that would be at least twice as heavy a book. And there are enough sort of introductory books that get you through the basic theory and the basic practicalities of like simple search algorithms, simple machine learning algorithms. So we assume that you know something about AI, and now you want to learn about how AI can be applied to games. And that is very much written for both academia and industry, but in a pretty academic style, in the sense that there's theory in there.
The idea started 2 years ago when myself and Julian, after have been teaching artificial intelligence in games courses for over the last decade or so, we sort of both felt that there was no such a book that could be used by our students. So that was our main drive. Let's actually write a book that our students can use, and maybe other students could use too.
We'd been teaching mostly from research papers for a while because there was nothing appropriate. There were a couple of other textbooks that were very much focused on the industry cases and not really connected to any of the research that's been going on, because there's been an amazing amount of research going on in the last decade and a half or so about AI and games specifically. And we wanted to write a book which, after having read this, you understood all the new stuff as well.
Yeah, this was the first textbook I'd come across that I felt was really a good theoretical reference. There are many books about how to do gaming on Android and how to do AI in Unity or very specific platforms, but nothing that really brought together the cohesive ideas. So I was glad I came across it.
I feel that there are a lot of people that when they hear about this, when they hear about AI in games, they only think that AI is whatever code controls non-player characters. And that's clearly a big part of it, but that's definitely not all of it. So we wanted to expose people to the wide array of applications for AI in games, which is, I mean, if there's one thing we want people to walk away with, is this eye-opener that, wow, there's so many different things you can do, and it's all connected.
When I think back to my childhood, I grew up, I guess I'm from the Nintendo Entertainment System generation. To the best of my knowledge, there wasn't really much that we would call AI there. It was really rule-based systems that controlled all the characters. The book, obviously the book will cover how to develop AI non-player characters, but there's more to it. Can you tell me a little bit more about those other areas that the book delves into?
We look at 3 broad areas. One is playing games. So as a player or as a non-player, you see a lot of papers on about playing Atari games or about playing Go or chess. We talk about that as playing games as a player, as if you would be a human. But then there's also the sort of non-player playing. So basically coming up with AI for controlling one of these little blobby enemies in Zelda or Call of Duty or whatever you want to. But then there are the two other big areas, generating content and modeling players. Generating content is creating game worlds or part of game worlds, such as levels or maps or textures or characters or something. And many people don't think about that as an AI problem. Some people think of it as only like, for example, a computer graphics problem, or that's just random number generation. But one of our main points is that if you think of this as an AI problem, you can do so much more, because there's all these search and optimization methods and, of course, machine learning methods that allow you to take content generation far beyond the sort of things you see in games these days. And then the final application field is modeling players, learning to predict how players will feel or what players will do. Now, all of this comes together because game playing and procedural content generation and player modeling are dependent on each other. If you can model how a player would react to a particular type of game content, then you can content for them that makes them do particular things, or generate levels that make them happy, for example, or generate puzzles that are incredibly frustrating or something like this for this particular player. And to do that, you often need very good game playing methods to sort of automatically test the content. We have this vision where all of this is really deeply intertwined. There is a lot of progress in game design and game development, which is only really enabled by approaching all these problems at the same time.
Yeah, I think that's an exciting vision. I know that a lot of game design today, or maybe historically, perhaps it's in the period of change, but it's been a huge task for one designer to develop all the content, to specify all the different pieces of it. Even though it feels like an open world, everyone's technically having the same experience.
Yes.
And there's this sort of dream of, oh, could it be totally adaptive? Could every experience be unique? A little bit like a tabletop Dungeons and Dragons game in that way, where, you know, all of the people are kind of creating anything.
Yeah.
How far are we from visions like that?
Oh, let's say October. No, but I mean, we are indeed pretty far from having sort of a computational dungeon master. So that idea, what you said, are Dungeons and Dragons, there, not only us, but quite a few people have talked about this ideal of the dungeon master that's totally adaptive, knows his players. I used to play a Swedish Dungeons and Dragons-like game when I was in my teenage years. And in a way, it's the most sort of complete challenge you can have, especially being a dungeon master, because you need to be thinking on your feet all the time, and you need to sort of come up with new interesting things for your players to do and react reasonably to whatever weird stuff they come up with. Once we have a computational dungeon master, we're pretty close to an artificial general intelligence. So one thing where almost all the game developers we talk to are really excited is particularly about procedural content generation. Once upon a time, you had a single developer being able to develop a complete game back in the early 8-bit era, complete with graphics and story and programming and everything. And then there were small teams, and there were bigger teams, and then there were bigger teams. And now it's like the biggest games can only be made by these huge corporate entities with hundreds of people. Yeah. Which is maybe not the way we want it to be.
So one of AI's sort of current objective, let's say, is to be an assistive tool during the design process for the different needs and the different creative capacities of the different people that design games. You know, an AI assistant that can actually help me, Kyle, Julian, across different tasks for sound design, for visual design, for level architecture design. But yes, we're not only using AI to generate particular games for our different players, but also assisting different designers by nature, having different needs during the creative process to deliver the best possible outcome. And best means, novel, playable, maybe surprising to their audience and so on.
So when I think of content generation, one of the examples that's popular that comes to mind is Minecraft. When you start a new Minecraft game, it even tells you, hey, we're generating, the mountains and the territory. And it is a truly unique experience every time you play. For the most part, I mean, with a few exceptions, it creates very natural and very diverse landscapes. There are things that are believable in the sense that a block world can be believable. I don't know that they're using any AI, though. What advancements can AI bring that extend those sorts of procedural content generation techniques?
And when you look at Minecraft, I mean, first of all, they made it somewhat easy for themselves. having this block aesthetic. You don't really need to sweat the details in the same way. We have giant voxels. What they actually use is a variation of a noise method, something derived from Perlin noise, where they basically have densities of objects in different parts of the world, and then that's transformed in a pretty straightforward way to where they're placing different voxels. Generally, the difference with the AI-powered solutions is that you can put in requirements that things are, for example, reachable, playable, finishable. For example, if you're generating a maze-like environment that you have for your dungeon, or a building interior or something, and you just use noise-based methods, then you're going to get things that look good, but you will have no guarantee that there is an exit to this building, for example, or that the treasure is actually in the dungeon, or something like this. You cannot really have much guarantees at all. But if you're instead using some kind of search method, such as evolutionary computation or Monte Carlo tree search for the level, then you can look at things in your fitness function or in your evaluation function. You can fit in things such as an automatic agent playing the game or playing part of the game and verifying that it's actually playable. That's a complete departure with the kind of methods that are used in, for example, Minecraft.
I see a huge appeal in being able to generate a level and then have the autonomous agent effectively be your QA, right? It can tell you the same way we have code coverage in unit tests, we could have level coverage, how many areas are accessible and these sorts of metrics. I know some game designers who consider themselves artists, and they're saying, this is my creation. I'm going to take care of every pixel or things like that. And that's sort of a Luddite approach. I think that idea will have to change in time as the tools become available. But how will game designers need to adapt to these new automation tools?
This is an ongoing process. And of course, artists will have game designers as artists or as software engineers. Gradually, they will look at the tools that we offer or the artificial intelligence that is available to them as a collaborator, right? Instead of looking at it as some sort of evil technology that will take their jobs, we're talking about a collaborator that can help you not only be more creative, but also maybe think outside your own box and come up with entirely new games. I think every artist that is out there that considers him or herself a game artist would consider the possibility of broadening up the creativity space, let's say. Having a machine that sort of enforces or repairs automatically things that we do might not necessarily be, the ideal form of collaboration. That might offend the artist, right? So we just need to give it a bit more free-form dialogue between artificial intelligence and humans. And I think humans will adopt this technology far easier.
You can see this in the context of how technology has revolutionized other art forms, such as photography. When photography came around, there were people worrying about whether painters were outdated and no one would paint anymore. And no, what we see is that we see a new art form, the art form of photography coming up. And we see a lot of hybrid stuff happening with like digital editing and painting and photography working together to create new visual experiences. That's what we're going to see with game design as well.
So I'd love to delve into that third area we haven't touched too much on yet, player modeling. And I think this will be foreign to many listeners. What do you mean when you say that AI can help with player modeling?
Player modeling is, let's say, an algorithmic process, a computational process that attempts to capture how you feel, or at least trying to approximate that feeling. And then, of course, what can you do with that? You can actually use it to generate the appropriate content for Kyle, because Kyle now is feeling frustrated, for instance. Or you can embed that to an agent that will tell you, now that I'm wandering in this entirely new level, I feel frustrated. So I need to tell you as a designer how this level would look or would feel, let's say, to a new player that would play this game. Or you can just inform designers. So this is what you can do with player modeling, understand players and use that information to make better games.
In terms of where we're going, kind of as a species, as game creators, things like that, what do we need more of? The game community embracing AI technology or AI people bringing better ideas to game developers?
We need in game development, okay, so I'm going to stick my neck out here a little bit. We need a little bit of a culture shift because For a long time, there's been this perception among people who develop games and people, specifically people who think of themselves as game AI developers, that anything that involves any kind of learning or any kind of unpredictable behavior is like, it's wrong, it's bad, it's unusable in actual game development because we don't know what's going to happen, it's going to wreck our whole game design, etc. When I started, both me and Jorgen started working on this back in 2004, 2005. Back then, if you talk to people from industry, they would mostly say that this is really interesting what you're doing, but we can never use it because the way we design games and the way you're basically carefully designing the player's experience in as much detail as you can. And now we're seeing people in game companies who are really, really interested in this and who think that AI is the future of game design. We see quite a few of those. But they are not necessarily the people who term themselves game AI developers. You find them often in other parts of the company, but specifically people in the analytics departments, but also people in R&D departments and all over really, and some designers, to be fair. What you need to do, one thing is to realize that you can make AI guarantee things. You can make AI test things and give you things that have actual guarantees that the level will be like this or it will play like this. But you might also need to think of design at another level, that you're no longer thinking about like carefully micromanaging every aspect of player interaction, but you will need to move to more high-level directing. So that's where I see a game designer as a role in the future, directing the AI systems that create the actual micro-level design. This means that you'll have to trust the algorithms involved, that they will be able to adapt the game in runtime so that some kind of general experience arc is followed, even though you can't control what happens all the time. So we need a shift of thinking with the AI tools, with the algorithms, and away from micromanagement.
Both of us and so many other academics on game AI have been training people that, and when they design games that have AI, place AI within the center of the game design process. It's just like you just have to do that if your game has an AI component, which was not the case decades ago, because AI would come in as a sort of final, sort of a plugged-in module that will come at the end, because we just needed a finite state machine to control for some agents. But I think things are changing.
So in the AI community, we have looked to games for quite some time as our benchmarks. You know, some time ago, Garry Kasparov was beaten by Deep Blue, and we could also point to Jeopardy and the challenge there, and most recently AlphaGo beating Lee Sedol. Do you guys have an opinion on what the new benchmark should be for AI researchers?
Many opinions. We can start with the conventional opinions. So, of course, apart from chess, Go, and Jeopardy, the other thing that's happening is poker. So we recently had results both from CMU and University of Alberta last year, where they have very, very good players for heads-up 2-player limit Texas Hold'em is weakly solved, meaning that there's no point in working out anymore, essentially. You're not going to get a stronger player. The conventional answer to the question you're asking about what's the next benchmark is StarCraft. So StarCraft is an amazing game, a game that has had a pro player scene for like almost 20 years, obviously has a lot of depth. You're not maxing out the game. You haven't found a dominant strategy, and it's unlikely to ever happen, which means that there is a lot to dig in here. And for an AI, it has challenges such as a very, very high branching factor, whereas chess allows you then to take 35 different moves on average every turn and go about 350. Chess has, depending on who you count, millions, at least millions. And it's very long, with many more turns if you want to speak to see it that way, because it's a real-time game, and it has a lot of hidden information. So people are working on this. So DeepMind, Facebook AI Research, and lots of academic groups are working on StarCraft. We're going to keep seeing improvements on that for several years. That's a standard answer, and that's a very good answer, and I like it, and it's great. However, you can also look at games such as, when are we going to beat humans in Dungeons and Dragons? When are we going to beat humans in Dixit, which is an association game which is based on essentially interpreting surrealist art together? When are we going to beat humans in Werewolf?
Anything that is beyond sort of strictly speaking decision making, I think is far harder. Of course, we can think of much harder games, and this is what we write at the book. We can even design harder games than StarCraft, and most likely there are harder games than StarCraft out there, more complex games. But these are games that humans don't really play. From a marketing and AI perspective, it might not make sense to actually solve them, if you see what I mean. And anything that is sort of non-objectively defined is much harder by definition, like social interaction, playful interaction, human communication. All of these aspects, if they exist in games, are far harder for AI to actually, deal with.
Well, it's great to work on solving a particular game. But what happens when you work on solving a particular game is that you overfit. Well, what's in machine learning called overfitting? You learn to solve one problem to the exclusion of others. Because we've had those competitions based on car racing and Super Mario Bros. And Unreal Tournament, which is a first-person shooter and so on. And what we get is that it's very, very agents. The Super Mario Bros. Agent can't play StarCraft or car racing, and the StarCraft agent can't play Unreal Tournament, etc. Another real, very hard challenge is to play many games. So this is, to an extent, is what we've seen with the Atari Learning Environment games, the Atari 2600 games that the DeepMind had a Nature paper on a few years ago. But even in that case, it's training neural networks to play only a single game. So a trained neural network for Frogger can only play Frogger. It cannot play Pac-Man, for example. So coming up with agents that can play multiple different games at the same time, we created something we call the General Video Game AI competition. You do whatever you want to create agent, but then you have to submit it. There are like hundreds of games available for testing your agent on. You submit it, and then in the actual competition, it's tested on 10 new games it's never seen before, which is much more of a general AI challenge, because you're no longer just trying to solve one problem, and you can't sort of use all your domain knowledge to engineer this particular solution. You have to try to solve the more general problem. So there's no lack of challenges.
Well, I can attest to the fact that someone that knows a little bit about AI can pick up this book and get value out of it. Who else is this book for? Should designers be getting this? Should programmers? What type of people will benefit from the book?
Well, anyone who's interested in AI in games and knows the basics of AI. So we very much want to see game designers and game developers to pick it up and read it. We wrote it as a textbook, so we're thinking that's going to be used in a lot of sort of CS-heavy or CS-based game design programs and individual courses on AI in games in universities. So it's particularly written to be easy to teach from, because it's built on our experiences of teaching similar courses for a long time. But really, just about anyone who has the basic AI prerequisites and an interest in games.
Well, to wrap up then, I guess, do you guys have any particular games that you're fans of specifically for the way they've used AI?
So when it comes to procedural content generations that are very well known for this and use this to very, very good effect. So the platformer Spelunky, which is essentially Super Mario Bros. Meets Indiana Jones, has you fighting your way through like new levels every time. Is pretty amazing because for the way it uses content generation to create like a good challenge, but like an always beatable challenge every time. Even though this is pretty simple BCG methods, everyone who's interested in content generation should play Spelunky. But of course, content generation is really, really central to a lot more games than people realize, such as, for example, 4X games such as Civilization. So Civilization would not be the same game, and it would be a much lesser game if it wasn't for the fact that the whole world is actually generated every time you play the game. If you love Civilization but don't have the sort of time to play it, get Battle of Polytopia for your mobile phone. That's Polytopia. It's so addictive. I'm going to send the developer a bill for lost months of my life, essentially. But then again, if it comes to AI, gameplay and AI, there are games that do, with very simple means, do interesting stuff. The Left 4 Dead series, which is great in both that they have kind of interesting difficulty scaling. So they have this AI director that throws more or less enemies at you and sometimes changes the scenery to sort of create a particular desired experience for you. And it also allows you to drop in and out of game characters. If you play the game and you lose connection, the AI takes over, and then you can drop into it again, and which is also like a simple trick, but nice and effective.
Now, on top of that, a milestone game is Black and White, a milestone game for AI. They managed to sort of interweave, put together very different AI methods, such as decision trees and belief, desire, intention models, and so on, into the same sort of game. That's my one little sort of independent game that I really like because it realizes parts of experience-driven procedural content generation, as Julian said, or player modeling is called Nevermind. So Nevermind is designed by Erin Reynolds. It's some sort of like biofeedback adaptive horror game, right? So it basically measures your level of stress using a multitude of sensors, and it tries to make you even more stressed by adapting the content of the game. And that would be my favorite games when it comes to AI in games.
Good recommendations. I'll have to check all those out.
Mm-hmm.
Well, thanks again, guys, for coming on to do this. I really appreciate you taking the time.
Yeah, thanks for inviting us.
Thank you.
Data Skeptic is a listener-supported program. To support the show, visit dataskeptic.com and click on the membership tab.